So today we're getting into day 2 of the unit circle, and we're going to talk about the sine and cosine links on the unit circle. So get the learning goal down, and then on the alternate activity worksheet, start following the directions with the exception at the top where it says you need to use the table of trig functions and formulas. You're not going to have to do that. But where it says number 1 on the unit circle, use a protractor to draw an angle of 25 degrees on the ray intersecting at point P and the other ray along the x-axis. So when you're dealing with that, it's talking about measuring from the origin an angle that goes out to 25 degrees and hits somewhere out here. Now that's not, I highly doubt that that's accurate, okay, since I just threw it in there, but we're looking for 25 degrees from here, from standard position out to there. So I'm looking for a 25 degree angle right there. Okay. Number 2, find the x and y coordinates of point P. Point P is this point right here where it hits. Okay. I want to know what those coordinates are. So what's x and what's y? And it says you're doing that by using a ruler. So be very accurate. Use inches. And then in the back of the textbook, we're not going to do that. We're not using the table of trig values. Okay, we're going to actually use our calculator. Okay, you're going to find what sine of theta. This is the Greek letter theta. Okay, we're going to replace theta. It's just like saying sine x. We're going to replace theta with the number 25. So that's going to be sine 25 degrees and cosine 25 degrees. And you're going to use your calculator to do that. Okay, find sine and cosine there. And then once you get to number 3, you can kind of pause. Once you finish number 3, excuse me. Okay, you can kind of pause. Questions? All right, go at it. Work with your partner. Okay, go ahead and wrap up your discussion, hopefully, about these. Riley, you got your seat? Okay. Okay, so we have our 25 degree angle, right?
Yep.
Okay. So in that case, if you've forgotten how to use your protractor, it's a good review. Okay, you line up your crosshairs there. You go, your 25 is less than 90, so we're using these bottom angle measures here. I got 25, and so if I'm being really accurate, I'm out there, right? And so from the origin out to that point, extend our line, and we've got point P about right there. Okay, so there's our ray. How many found x and y coordinates for it? Okay, what were our x coordinates? 7/8, I hear? Yeah? Okay, let's check it. So we're really looking for this to drop down right here, right? So if I'm trying to find x, I'm trying to find this point right here. And so that means I've got to measure. So if I'm using my cool ruler, I'm going to actually start at 1 so I'm not cutting anything off there. And it looks like if I go, it looks pretty close, about 7/8, 5/8. What do we got here? About 7/8. How many got 7/8?
I got 15/16.
15/16. So 14/8. Okay, so 7/8 is 14/16. So 14, 15/16. Can we say 14.5/16?
That'll work.
All right, so I'm going to go with 14.5/16. Just because that's in between 14/16, which is 7/8, and 15/16. So 14.5/16. Now it's not good form to put a decimal in a fraction, but for this we'll make an exception there. Okay. How about y?
7/16.
7/16. Anyone get anything different?
3/8.
3/8. So 7/16. That would be 6/16. So should we go like 6.5/16? All right, 6.5/16. So if we're measuring that, let me just make sure that I agree as well. So yeah, I got about 1, 2, 3, 8. So 6.5. Yeah, we'll go 6.5. 6.5/16. Cool? All right. Change it to decimal form for me. Okay, so out to the 10,000s, 4 decimal places. What does that make this? 0.90623. Okay. How about this one?
0.4063.
0.63. Okay, very good. All right, so we're saying that this length right here has a length of 0.9063. Okay, and I'm going to run out of room on this one. I'll use my pen. 0.4063. So really run out of room. Okay, but really that's this length. So that's this. Okay? And we've got this length right here. Okay. What is the cosine of 25 degrees? This angle. Now here some of you are going to get some different numbers, but let's see if we can find the cosine of 25 degrees. What'd you get?
About 0.
Point.
906.
Oh, exactly that? Yeah. Well, isn't that convenient? All right. Did everyone get 0.9063? Did anyone get something different when they put cosine 25? How many? Did everyone change it to degrees in their calculator? Yeah. Can I borrow your calculator? All right. Hey, if you're not getting 0.9063, then you need to go to mode and go down to where it says radians, degrees. You want to be in degree mode right now. Okay? And then try it. How about the sine value? Sine of 25.
I got 0.4.
0.4? 226. Okay, sine of 25. Hey, it's pretty close to these values, right? This one's like exact to 4 decimal places. This one's pretty close. All right, we're a few hundredths off, a couple hundredths off. Hey, that tells us, at least that shows us in this case, we can keep doing this for many different angles, but this length right here, our x length of this right triangle, is called our cosine. Cosine goes with x. This length right here is called our, this is our sine. This is your x value. Sine is your y value. Okay? Cosine and sine. All right, so when we say what is the coordinates of an angle moving from standard position around the unit circle, when we say this angle is 25, if I want to find the coordinates of it, I just need to do the sine of 25 to find the y value, the cosine to find the x value. You could actually draw in your angle every time, I guess, on a unit circle and measure it out like this, but it's a little quicker if we go the other route. All right? I think you got it. Guys, the reality is here, I could just come into class and say, hey, everyone do number 7 on your calculator. Do sine 15 and cosine 15, and then give me the values, and then you're done. But you have no visual representation of what that means. When you're dealing with a unit circle, you're creating a right triangle as your ray moves around the unit circle. So, for instance, if I took and I drew in this angle right here, let me just pick an angle. Let's say it's let's say I have that one right there, and we'll call that a 65 degree angle. Okay? So from here to here, let's say that's 65 degrees. I could draw in a right triangle and calculate the sine and cosine of that. Okay, and we can measure it, and notice my right triangle now, my y value is longer than my x, so that means my sine is going to be, in terms of x and y, which one's going to be bigger? Sine's going to be bigger. I want everyone to calculate what the sine and cosine of 65 are.
What?
What's the cosine? Noah? Well, that's weird. 0.4226? Weird. How about the sine? Dude, weird. How's that? Are they always going to just be these numbers? Maybe I'm lying to you. Maybe you don't. Maybe they just always, maybe sine is always this and cosine. I mean, maybe they just use those and move them around. Hey, guys, there's a logical reason why these just traded places. Hey, go ahead and talk with your neighbors real quick.
So they're both 25 degrees
95.
off of one of the axes.
They add up to
Axes. Because the y-axis is 25 degrees.
All right, Jacob, what do you got?
So that's
And then 65 degrees of the x-axis.
Good. Hey, guys, Jacob's description is their complementary angles, 65 and 25. Okay, Andrew, what are you saying?
I'm saying that both of them are 25 degrees off of one of the axes.
Good. So this one, if you go 25 degrees this way, you're dealing with a 25-degree angle. Okay? So, yeah, there's different patterns you're going to start seeing, and that really has nothing to do with what we're doing today. I just wanted to make your minds explode for a minute. So, that's kind of fun. All right. Anyway, note that the y, the sine value, got bigger because this length right here increased. And the cosine value got smaller because this length decreased. All right, and it does deal with that 25 and that 25. That's how I knew they were going to trade places. Okay, hey, I want you to go ahead and do these problems right now. Find the cosine and sine of each of them using your calculator, please. Okay, go ahead and check your work there. See how you did. Hey, any questions? Good? All right, everyone rate themselves 1 to 5.
7.
Okay, so just so you're clear, today you get a round. You got to use your calculators, all that. Tomorrow we dive into the special angles. They're really, really special. All the special ones they were talking about yesterday, they're so special. Okay? And they have to be exact measurements. They're the ones you're going to memorize. All right? Now, if you pay close attention in today's lesson, we started talking about the 25 degrees and complementary angles, and it also works with supplementary angles. Sometimes on some of the angles you get today, you may realize, let's say you do a 20-degree angle and a 70-degree angle, you may realize that those just trade spots because they're complementary, okay, which can save you a little time when you're doing your assignment. Okay? Any questions? Why don't you take out yesterday's assignment, let's score that up, and then we'll go get today's